So this is a table called a frequency table, and I know it looks super complicated and it's not easy to put together, but the end result is going to be so worth it. It's going to take data that's really hard to sift through, and the example that we're going to use is electoral votes for each state. If you just look at this list of electoral votes, it's hard to kind of get a gauge on how that data is distributed. And so that's the reason that we're going to go through this process today. We're basically going to split the 50 states plus DC into groups, into classes. So the word class is the groups. And so you'll see that I have my table set up here to do 1, 2, 3, 4, 5 classes. So we are going to split this data up into 5 categories. Now I'm not just going to split it equally and put 10 states in each one. I'm going to think about the numbers in there. Now the way we decide how to split the numbers is by determining the class width. And the width of each class is like, should I go from 1 to 10 and then 10 to 20, or how should I split that? And so there's a formula for that. You're going to take the maximum number minus the minimum number, and you're going to divide by the number of classes you want to make. Now there's one extra step. That is a lot of times a decimal, and even if it's a whole number, what you want to do is then round up. And the reason you want to round up is because if you don't round up, all of your data might not fit into the classes that you make. So let's do this one as an example. What is the maximum number of electoral votes? We've got California at 55, and the lowest is 3, right? We have a lot of states with 3. So we're going to take 55 minus 3. And I've already decided from that table that I'm planning to split into 5 classes. So we've got 52 divided by 5, which comes out to 10.4. And we don't just round that, we round it up. So we are going to round that to 11. So we would say that the class width is 11. Now let me show you how to use that. We're going to go back to our table and set up our class limits. We know that there's going to be 11 numbers in each class. And this is a little different, so pay attention. We're going to start our class limits with the lowest number. So we're not going to start at 0, we're not going to start at 1. We know that the lowest number of electoral votes is 3. I'm going to do all the first numbers first. I think that's the easiest way to do it. So it's going to go 3 through something. But what I'm going to do is I'm going to take that and add that class width of 11. Add the class width of 11. All right, and I don't want these classes to overlap in any way. If I have somebody with 14 electoral votes, I want to know exactly which class it goes into. So this first class is going to go from 3 to 13, and there's no question. The next one is going to go from 14 to 24. I'm just kind of looking at this next number to decide what my upper bound is there. Next one's going to go to 35, 46, and then sometimes the last one's harder for me to figure out, but if you notice, these are also going up by 11, so that helps me. So if I add 11 to that last one, 57. Now I know it looks like from 3 to 13, that only looks like 10, right? But if you count on your fingers, that's actually 11 numbers. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is 11 numbers, and so the class width would make sense. Now eventually we're going to graph these, and we don't want to have any gaps between our classes. So class boundaries is going to take care of that. So class boundaries basically goes a half a point below and a half a point above your class limits. So this first one, the class boundary would go from 2.5 to 13.5. The next one, half a point below and a half a point above would be 13.5 to 24.5. And that way we're not going to have a gap between class 1 and class 2 here. They'll fit nicely together on our graph on our number line. Next is the class midpoint. If you remember the midpoint formula from the old days, that just goes x plus x divided by 2, y plus y divided by 2. And so, for example, on this first class, if I look at those class limits, 3 plus 13 divided by 2 would be 26 divided by, 16 divided by 2, which is 8. And so we're just going to find the average of the lower and upper bound each time. 38 divided by 2 for this next one, right? Is that 19? The next one would be 60 divided by 2, 30. And actually, did you notice that these are going up by 11? So if you're sure you've got your math right, you can use that to complete the midpoint part. For the tally column, I'm finally going back to this raw data, and I'm going to put each state into its class. And so what I'm going to do is I'll start with Alabama. It's got 9. So I will put a tally in the class that contains Alabama. Alaska has 3. So I'll put a tally in Alaska. And I'm just going to continue that for each of my states. Well, that was a lot of work. Aren't you glad I did it for you? The frequency part is where we just kind of count up our tallies. So I've got 5, 10, 15, 20, 25, 30, 35. I've got 40 in that first class. 7, 2, 1, and 1. And I always like to check to see what that adds up to make sure that I did my counting correctly. So 40 plus 7 plus 2 plus 1 plus 1 is 51, which shouldn't worry me because 50 states plus DC, 51. Excellent. Relative frequency. Relative means comparative, right? So we're going to compare that 40 to the total. And we're going to compare the 7 to the total. And we are going to put those into decimals, or a lot of times you'll see them as percents. And then you can double check those numbers just to make sure that it all adds up to 100%. Now, with the rounding, if you're a little bit off, that is just fine. We have completed our frequency table. And by including that last column, we've also made a relative frequency table. Now that we finished our frequency table, we can construct our histogram. The histogram, the way this will always work is the x-axis will always include your classes. And so in this example, our classes are the number of electoral votes. And we're going to number the x-axis based on those class limits, actually the class boundaries, because like I said, that's more of a number line sort of thing. So let's see if we can get this going. So sometimes I just put a little because I know that I'm going to start at 3. Well, actually not at 3, at 2.5, because remember I'm looking at that class boundaries spot. And since these are equally spaced, you can really just make them equally spaced when you number them on your x-axis. Now the y-axis for a histogram is always going to be the frequency, but we want to think about what does that stand for. The frequency in this case is the number of states with that number of electoral votes. So I'm going to label this as frequency, but then also describe what it stands for. So number of states. And then overall, we're going to want a title. So I would say, since it's a histogram, it's going to show the distribution. Of electoral votes in the US. Great, it is time to start making those bars. So you'll see that our data, our frequency varies from 1 in certain classes up to 40 in other classes. So I want to pay attention to that 40 and mark up this axis so that we reach 40. And then we're just going to draw in the bars for the histogram. So this first class goes up to 40. And then just to make it a little more clear, why don't we label that frequency on top? Just so nobody is misled, we can actually get some solid numbers out of there. That is our very first histogram. And now we'll go ahead and do our relative frequency histogram. The beauty in this is that everything is set up the same way to start. Except on the y-axis, it's not just frequency, it's relative frequency. And we can reflect that in the title as well. And now, since we're doing relative frequency up the y-axis, we will number a little bit differently. We're basically going to use percents or decimals. I'm going to go with percents this time. And our highest is that 40 out of 51, so 78%. So I'll want to get up to probably 80% on my y-axis. And you should notice that there's really no difference in the shape of this graph compared to the regular histogram because it's using the exact same data. So the relative frequency histogram, just useful if you wanted to look at percentages rather than actual numbers, but same idea. Fun facts about histograms: the bars must touch because that's how we set up our classes. There aren't any gaps. The height will always indicate the frequency. That's always what the y-axis stands for on a histogram. And our x-axis is always numerical. That's why we number it like a number line. Now, if you look at a bar graph, similar in idea, but the bars don't always touch because it doesn't make sense for them to touch like it does on histogram. This bar graph, actually, the height does represent frequency, and I think that's probably true of a lot of bar graphs. And you'll notice that the x-axis is not numerical, so that would not count as a histogram either, because this is just kind of more of a nominal type of data, right? Why do we use frequency tables in histograms? We're really just looking to see how the things are spread out. Another word for that is the distribution, how those numbers are distributed. It also makes it really obvious if you have any outliers. If you have this random bar that pops up somewhere else, you'll see that better than you would see it on a data table. And obviously, seeing those high and low frequencies, it was really easy to see that most of the states are in that lowest class for number of electoral votes. These are some vocab words that I will ask you about again. When you look at your histogram, you should be able to describe it using statistical words. And so if you see a histogram that's kind of shaped like that, we call that mound-shaped symmetrical. And if it's more of all the bars are equal, we call that uniform. Everybody's wearing the same thing. Bimodal, remember mode means most, and so bimodal indicates that we have two categories that are the most. Skewed left and skewed right. I think that looking at those make sense, but when you think about skewed left and look at this graph, did you notice that we actually have most of the data on the right? So that can be a little confusing. So what I picture is taking my left hand and swiping the data over, and that's how we skew left. It's by taking our left hand and skewing left. And skewed right, imagine taking your right hand and whacking the data over to the side. So that's skewed right. If you used your right hand to skew the data over, that would be skewed right. Sometimes those feel a little bit opposite, but I think that's always done a good job of helping me remember how those are defined. I'm so glad you're still with me, because cumulative frequency, accumulating, right? Cumulative frequency is just a little bit different. Here I have my data from earlier from the frequency table. Cumulative means we're going to see how much we've accumulated. So by the time we get up to 13 electoral votes, how many states have been accounted for? 40 of them. By the time we get up to the end of the second class, once we get up to 25 electoral votes, 24 electoral votes. How many of the states have been accounted for? The 40 from the first class and the 7 makes a total of 47. So that kind of shows us that a big majority of the states have 24 or fewer, yeah? And then we're going to keep accumulating. By the time we get past this class, we've got 49 accounted for. One more would make 50. And finally, that last state gets counted, and we've counted all 51. Now we're going to put those to a graph. And the name of the graph is called an ogive. Ogive. And we are basically just going to build this just like the histogram to start out. You'll notice that I did have to go up a little higher on the y-axis because 40 will not be my high this time, 51 will be my high. Now this is not going to look like a histogram, it's going to look more like a line graph. And so how many states have fewer than 2.5 electoral votes? The answer is 0. That very first class boundary is always going to start at 0 because there aren't any less than that. By the time we get to 13 electoral votes, how many states have we counted? We've counted 40. 7 from the next category brings us up to 47. And then we had 2 more. And then we had 1 more. And then we had 1 more. And we're going to connect those with lines. So an ogive will always be an increasing graph. And I'm not sure my numbers did a very good job, so I'm going to label those. So on an ogive, it's really the slopes that tell the story. The steeper the slope, the more frequency, the more states that we would have in that class. These almost look flat, right? And that's because we only had 1 state in that group and 1 state in this group. So the reason that those almost have a slope of 0 is because we had almost 0 in those categories. So again, we would be looking at the slopes to determine the frequency. But an ogive shows how those 51 states accumulated, mostly starting in that first section and accumulating a little slower once we went to those higher classes. An ogive.